basically we gotta go, he wants me to go through and explain why it can't be SN2, E1, E2, or SN1, like, you know, it's sterically hindered. Yeah, for that one, so. I've been looking through my notes and I just haven't found, I remember him talking about it yesterday, I just don't have it in my notes, unfortunately.
Easy.
Because it's in the PowerPoint.
See if I can draw this. I have too much in there, probably.
Yeah, that's it.
So, what kind of alkyl halide is it? What type?
Secondary. No, tertiary.
Tertiary, right?
Yeah.
It's a tertiary. And does SN2, is it very reactive for tertiary?
No. It'd be an SN1 most likely.
Yeah. And so SN2 wouldn't be very reactive, but if you also think about it, an SN2 results in a conformation shift, where it would come from the backside, everything flip. It's in this really tight ring.
Okay.
Everything else doesn't want to flip because if it flipped,
Yeah, the rings don't.
Yeah, there's not enough. There's not enough flexibility for there to be a conformation shift. So that's why I say for SN2 there, you can't have an inversion of stereochemistry there.
Okay. And then for the E1 and E2 eliminations, it would create an E1 or E2 would create a double bond somewhere, wouldn't it? So it would have to put a double bond on one of those 3 carbons.
Yeah, and I'm trying to think. I think one reason is you don't have necessarily, and the way I drew up here, it probably doesn't look all that great. But I think like that the top hydrogens up at the top peak there, you don't have beta hydrogen. You don't have hydrogens that are anti to it.
Oh, okay.
And
it's in a different plane, or
yeah, just because like if you imagine this bromine's sticking out towards us, but those hydrogens up top are going to the side, so they're not anti that bromine. And it's kind of hard to picture like where hydrogens would be. Well, they're just not. They're not really anti to the bromine. And you could also probably say if you form a double bond, that's going to cause it to be these carbons to be trigonal planar, and then like you can't really have. It wouldn't work so well for these bonds to be trigonal planar. Just so I probably put that too.
Does it work just cause sterics? Or
Yeah, it would cause a lot of angle strain.
Angle strain? Oh, okay.
So I put one reason, like it doesn't look like there's any anti-hydrogens, and you also wouldn't have, you'd have some angle strain. And then the next one, talking about a carbocation. If you had a carbocation here, that makes that bond be trigonal. It has to be trigonal planar. In that picture, I mean, it looks like it's trigonal planar here, but I guess I didn't draw it all that great, so it's more like this, more flat. But since it's going to be trigonal planar, it's going to force that bond to be 120 degrees, which is going to cause an angle strain in all of those locations, really.